Hi, and welcome to this meteorological video on gradients. And what is a gradient? Well, as the definition shows there, it's a change. We use it in meteorology, but it's used in a lot of other sciences, and it represents a change in some property over some distance. So the property can be just about anything. In meteorology, we talk a lot about temperature gradients and pressure gradients. You've probably heard of that before. Moisture also is a gradient, but there are a lot of other types of properties that we can measure the change. And in meteorology, we'll be doing that. So a gradient is a vector, and as you know, vectors have magnitude and direction. And it's important to note that gradients always point towards higher values, and that the gradient vector is perpendicular or 90 degrees to the isoplus. So always point towards higher values and 90 degrees to the isoplus. There it doesn't look like it's 90 degrees. It's kind of my fault. I probably should have drawn an arrow that's a little bit better. The shorthand that we use for the gradient is the Dell Operator, and here we have examples of the Dell Operator with pressure and temperature. The Dell Operator is something that we use in vector calculus to indicate a change in perhaps more than one variable, one direction. So in other words, pressure can change in a lot of different directions. Maybe we use X and Y, or we can also use natural coordinates. Speaking of which, the type of coordinate system that you use is pretty much open. You can use Cartesian coordinates or natural coordinates, whatever works best for the situation. So as I mentioned, the Dell Operator is something that's used in vector calculus, and there you can see the calculus. There's partial derivatives, which are changes in only one direction. In this case, I'm showing you changes in the X direction and also changes in the Y direction. Now, if it was, for example, pressure, you'd have changes in pressure in the X and changes in pressure in the Y. The I and J are unit vectors to indicate that that's in the X direction and also in the Y direction for the J. In natural coordinates, you would have changes in the S and N directions. So let's practice what you've learned. Here you have a surface chart looking at a pressure gradient. That's what those black lines are. You can see a cold front pushing through Oklahoma and Kansas. Which direction are the gradients pointing, pressure gradients, at point A, B, and C? Now remember, gradients always point towards greater values. So where is the higher pressure? This slide shows that the pressure is higher to the south and also southeast and southwest of these points. And remember that the gradient always points perpendicular to the isoplus. So at point A, it's pointing basically 90 degrees to the southeast. Same with point B pretty much. And then point C, it kind of changes and points a little bit to the southwest, but it points to higher values. You can see at point C particularly there are two isobars, one which is 1008 and the one to the south is 1012. So at point C it points to higher values of pressure, and it points perpendicular to the isobars. Here are temperature gradients on an 850 millibar map at point A and point B and point C. And you have colder temperatures to the north and east and warmer temperatures to the south and west. So looking at these points at point A, you can see that the temperature gradient is pointing towards, of course, red, towards higher values, and 90 degrees to the isoplus or isotherms. Point B, it kind of points a little bit to the southwest, but it's still 90 degrees and to higher values, 90 degrees to the isotherms. And point C, it looks a little bit convoluted there, but it looks like higher values are found to the south. Let's try theta E. Now remember, you can do gradients of any scalar value. And we're looking at points A, B, and C. and these are equivalent potential temperature. Remember, equivalent potential temperature is a measure of the temperature and also moisture content in the air. So higher values means that there's higher moisture and temperature together. So on this particular June day, you could see that there are higher dew points or higher moisture values and higher temperatures in the combination we call theta E, kind of across the central United States near South Dakota and also Nebraska. So at these points, at point A, it points 90 degrees to the isoplus towards higher values. Same thing at point B, and also point C, 90 degrees and towards higher values. I hope you learned something from this video about gradients.